Hi, my name is Leen, and in this video I would like to introduce one of Renesas' newest microcontrollers, the RA2L1. First, let's position the RA2L1 within the RA family. Overall, the Renesas RA family lineup can be separated into 4 series, starting at the top. The RA8 series is the top-end product which aims for the highest integration and the highest performance. This series will be introduced late this year. The RA6 series offers the widest integration of communication interfaces, including Ethernet, as well as a TFT display driver and advanced security features. The RA6 series is equipped with either a Cortex M4 or Cortex M33 core and runs at up to 200 MHz. From a security point of view, the RA6 series supports full security integration, making these devices widely desired in security applications. The RA4 series bridges the needs of reasonable low power with the demand for reasonable connectivity, memory densities of up to 1 MB of flash with a wide range of communication interfaces. The RA4 series is also equipped with either a Cortex M4 or Cortex M33 core and runs at up to 100 MHz. At the bottom you can see the RA2 series, targeted at low power applications. To achieve the best performance, special power down modes are provided. These devices use the Cortex M23 core, running at up to 48 MHz, and support a wide single voltage supply from 1.6 to 5.5 volts. Here you see some more detail on the various RA series currently available. The RA series was introduced on October 2019 and currently covers 121 devices in 3 series and 12 groups, covering various package sizes and memory sizes. This video will focus on the RA2L1. Now let's get into the specifics of the RA2L1 device. Let me jump right into the key benefits of the RA2L1 and start with a summarized list and drop down to cover each area in more detail. Starting with box number 1. The RA2L1 offers a low power operation and is designed for ultra low power consumption. This device consumes an operating current of 64 microamps per megahertz and has a software standby current of only 250 nanoamps with a less than 5 microsecond fast wake-up time. It has a flexible power architecture and several power modes to achieve lower average power for multiple applications. The second benefit is higher integration of peripherals. The Renesas MCU incorporates a 48 MHz Cortex M23 CPU and innovative peripherals such as an enhanced capacitive touch sensing unit, highly accurate analog features and timers. In addition, security and safety features are implemented in hardware. Benefit number 3 is the lower BOM cost or bill of material cost that can be realized using this device. The RA2L1 enables system cost reduction because of its high integration of functions that are normally added externally. For example, a ±1% accurate internal oscillator, eliminating an external crystal in many cases. High current drive and 5 volt tolerant I/O pins, wide voltage range of 1.6 to 5.5 volts, thus eliminating an external LDO. Implement power on reset, low voltage detect, watchdog timers and EE2PROM. Benefit number 4, ease of use. The RA family provides a software package that includes best-in-class HAL drivers. This code comes in C source for free. In addition to the user-friendly flexible software package, and development can be done using the third-party ARM ecosystem tools or using the free Renesas E2 Studio Integrated Device Environment, or IDE. In terms of solution advantages, the RA2L1 offers the best-in-class low power consumption in 32-bit microcontroller. In the most common operating modes, the RA2L1 consumes an operating current of 64 microamps per megahertz, while operating in DC-DC mode and 114 microamps per megahertz in LDO mode. The sleep mode of this device stops CPU operation, reducing overall microcontroller current consumption by 80%. The software standby mode disables the microcontroller's on-chip functions, reducing power consumption to the lowest level possible. The RA2L1 typical software standby current is only 250 nanoamps, while the RTC software standby current is 360 nanoamps. The RA2L1 also boasts quick recovery time from software standby mode and wake-up time in less than 5 microseconds. In snooze mode, the CPU is in the standby state, while AD conversion and serial communication are still enabled, so the CPU is activated only when required. This mode is excellent for battery-operated systems as it greatly increases battery life. As you can see in this image, the RA2L1 has an excellent combination of normal and software standby, and quick wake-up time from software standby mode, which is the key to reduce the average current. An example of the high integration of advanced peripherals, let's look at the Capacitive Touch sensing unit. We see lots of Cap Touch MCUs in the market today. However, they are very often software based, meaning that the CPU must spend a large amount of time performing all the operations. And as illustrated on the left of this image, the CPU's time must be distributed to achieve both touch and system control tasks, as well as the after-touch measurements, meaning that the MCU will be required for post-processing to determine touch, on-off or additional filtering. The RA2L1 combines capacitive touch sensing capability with system control functionality, all in a single chip solution. Its specialized touch hardware, called CTSU2, can realize full scanning and processing with less than 15% CPU utilization, as the RA2L1 touch detection mechanism has also been architected to minimize overall power. The CTSU2 provides enhanced use cases under a variety of conditions as illustrated on the right here. For example, it can support sensing through acrylic up to 10 mm thickness and also implements proximity sensing or hovering at a distance of up to 10 cm. This is particularly important as it accommodates limitations related to hygienic or safety applications. Finally, noise tolerance meets the requirements of IEC 61000 4-3 Level 4 and 4-6 Level 3, ensuring reliable operation with minimal sensing errors. Let's move on to our next advantage, lower BOM cost. The RA2L1 enables customers to achieve reduced system cost and smaller overall system size because we have a high precision, 1% accurate, high-speed on-chip oscillator, power on reset and low voltage detectors, background operation, data flash supporting 1 million program and erase cycles, and a temperature sensor, and so much more. And like other Renesas MCUs, the RA2L1 has a number of safety functions, and that allows customers to test and validate normal operation. Renesas provides an IEC 60730 self-test library to perform self-diagnostics on microcontrollers free of charge. The next advantage, ease of use. As already mentioned, the RA family is provided with a flexible software package. The FSP includes production-ready HAL drivers and easy-to-use APIs to access the RA2L1's peripherals. Renesas HAL drivers are industry best-in-class drivers with high performance and a low memory footprint, with portability between devices in the RA family. Research shows that Renesas drivers are 40 to 60% smaller in size than competition. In this block diagram we can see the RA2L1 group, shown here on the right. The RA2L1 includes the ARM M23 CPU core with up to 48 MHz frequency, operating from 1.6 to 5.5 volts. The RA2L1 is offered with flash sizes of 128 and 256 kilobytes. There are several communication interfaces including CAN, 2 I2C, 5 SCI, 2 SPI, and an extensive timer set consisting of 4 32-bit and 6 16-bit general purpose timers, and also 2 low-power asynchronous timers. The RA2L1 finally has a 12-bit ADC with 19 channels and 12-bit DAC with up to 32 capacitive touch channels. The device also incorporates elaborate safety and security features to complete the package. Regarding evaluation boards, there are currently 2 options. The evaluation kit is the recommended option for customers who would like to evaluate the RA2L1 peripheral functions. This ecosystem-friendly kit encourages customers to jumpstart developing their next embedded system. The kit features serial connectivity, onboard debugging, and provides unhindered native access to all MCU I/O pins. The Capacitive Touch evaluation system is the best option for customers who would like to evaluate the RA2L1 Capacitive Touch sensing unit more deeply. Using this kit, they can easily evaluate keys, sliders, and wheel functions. The MCU and kit part number ordering information is detailed on this table. As you see, there are 20 different part numbers with varying memory size, temperature range, and package type. The parts listed in yellow are recommended for sampling. In closing, I would like to thank you for your attention, and if you have any questions or recommendations for future videos, don't hesitate to contact me on this address. Thank you for your time.